Okay, so let's take a look at this one. The sum of 3 consecutive numbers is 57. So what I have is I have 3 numbers. I have the smallest, the middle, and the largest. They are going to add up to 57. It's the sum that we're looking for. So if I define one of them to be x, and it's generally easier to define the smaller one to be x, what would the middle number be? Well, consecutive means like 6, 7, 8, or 21, 22, 23. So x plus 1. There we go. We could make it y, but then we're dealing with the systems of equations. It becomes a little bit more complex problem. What's the largest one going to be? Perfect. X plus 2. So it's 1 larger still. Now we can combine the numbers, or combine what we can here. We've got x, x, and x make 3x. 1 and 2 make 3. So 3x plus 3 equals 57. Then what? Subtract 3, solve for x. We have 3x equals 54. And then divide by 3. X equals 18. All done? No, it says find the numbers. We found x is 18. That's the smallest number. X plus 1 would be 19. That's the middle number. Of course, 20 would be the largest. So the tricky part of those is just defining the variables. The math behind them, once you have the variables defined, is relatively simple. Okay, when we left off last time, we had talked about decimals and converting. We had 0.465, and we wanted to convert it to a fraction. Well, to convert that into an exact fraction, I should say exact fraction here, I'm just going to rewrite it in its fractional form. Remember, these decimals are actually what we call decimal fractions. That would be pronounced 465 thousandths. As a fraction, it literally is 465 thousandths. Remember, 1, 2, 3 decimal places, there's 1, 2, 3 zeros in our denominator. Now, of course, we're not going to leave it like that. What can we do with it? Both can be divided by 5. So 465 divided by 5 is going to be 93. 1,000 divided by 5, 200. 93 over 200, can that be reduced? No, it cannot. 93 can only be divided by 3 and 31. 200 can't be divided by 3 or 31s. We did addition and subtraction. If I have 73.8 plus 5.627, when I go to add these, what do I have to make sure I do? Line up the decimal point. So I'm going to write out my 73.8. I'm going to put my decimal point right below the other one. Then I can fill in the other number. I'll fill in before is 5. Afterwards is 627. This is plus still. Then I'll go ahead and fill in my missing decimal places with zeros. Then I can add. 0 and 7 is 7. 0 and 2 is 2. 8 and 6 is 14, so it's 4. Does the decimal point affect me carrying the 1? No, it doesn't. The only thing the decimal point affects is before I can do the next column, I do have to bring it down. There you go. 1 and 3 is 4, plus 5 is 9. 7 and nothing makes 7, so 79.427. For subtraction, we can run into things like this, 283 minus 17.6438. I want you to try that in your notes without a calculator for me, and I'll give you a minute or so, and then we'll take a look at it. So to set this up, I have my 283. Where's the decimal point on that? It's right at the end. If there's no decimal point, it's at the end. So I'll put a decimal point right underneath that one. Fill in my 17, 6438, and we are subtracting. So I'll fill in my missing digits here with zeros. There's 4 zeros. And now, of course, 0 minus 8 can't be done, so we have to borrow. Nothing to borrow from here, so we got to go all the way over to here to borrow. So that becomes a 2. This is now a 10. Now we need it all the way down here, so we have to keep borrowing. This will become a 9, and now this is a 10. Again, 9 and 10, and one more time. 9 and 10. So now we can subtract. 10 minus 8, 2. 9 minus 3, 6. 9 minus 4, it's 5. 9 minus 6, 3. Decimal point comes down. 2 minus 7. We got to borrow. It is 7 and 12. 12 minus 7, 5. 7 minus 1, 6 and 2. How many of you had that one? Good. Then we also did converting to a specific fraction. Let's say I have 0.684 inches and I want to go to the nearest 1/16 of an inch. To do that, I'm going to make this 0.684 over 1. I've made it into a fraction without changing its structure yet. Right now, it has a denominator of 1, and I want it to have a denominator of 16. So I multiply by 16 on top and bottom. Gives me 16 on bottom. 0.684 times 16. 10.94. So what that's telling us is that this is between 10/16 and 11/16. Which one's it closer to? Well, the decimal point, the 9 would say we're going to go up to the next one. So it'd be 11/16. Think of it as rounding to the nearest 1. So this is the ones place right here. So the next digit tells us that has to go up. Well, our next step for tonight is we're going to start looking at multiplication and division. Excuse me. Multiplication. I have 3.27 times 0.53. Do I need to line up the decimal points? No, I don't have to. This one, however, will line up on its own. Oops, 0.53, not 0. And I'm going to multiply it just like I would any other numbers. I'm going to ignore the decimal point. 3 times 7 is 21, so 1 carry the 2. 3 times 2 is 6, plus 2 is 8. Ignore the decimal point. 3 times 3 is 9. Now before I move over and use the 5, I'll fill in a 0 here. Put a line up here so I know that 2 has already been used. 5 times 7, 35, so 5 carry the 3. 5 times 2 is 10, plus 3 is 13, so 3 carry the 1. 5 times 3 is 15, plus 1 is 16. So I'm going to go ahead and add those numbers. 0 and 1 is 1. 8 and 5 is 13, so 3 carry the 1. 1 9 is 10, 3 is 13, so 3 carry the 1 again. 1 and 6 is 7, and 1. Where does my decimal point go? Between the 1 and the 7. Perfect. How do I know it goes there? Sure. We were taught to count 1, 2, 3, 4 decimal places in the problem. And we start at the back side and go 1, 2, 3, 4 decimal places in our answer, right? Well, again, why? Well, we've said before, when we multiply, we combine counts, but we also combine the names. This is hundredths. This is also hundredths. Hundredths times hundredths better give us 10,000ths. So counting those decimal places and putting that many decimal places in the answer is just combining the names. Now also you'll notice this is about 3 and this is about 0.5. 3 times 0.5 or 3 times 1/2 is 1.5 or 1.5. I'm expecting my answer to be close to 1.5. So 0.17331 would not make sense. 17 would not make sense. The only place for that decimal point to go that makes any sense is right there between the 1 and 7. So in your notes, I want you to try 3.4 times 26.8. I'm going to give you a hint right off the bat. You can, when you multiply, change the order of the numbers. I'd put the 3.4 second. It'll save you some time. So we start out with the 4. 4 times 8 is 32. So 2 carry the 3. 4 times 6 is 24. Plus 3 makes 27. 7 carry the 2. 4 times 2 is 8. Plus 2 is 10. So 0 carry the 1. I'll put a 0 here. Put a line up here. Now we move over to the 3. 3 times 8 is 24. So 4 carry the 2. 0 and 2. There we go. 3 times 6 is 18, plus 2 is 20. So 0, carry the 2. 3 times 2 is 6, plus 2 makes 8. And now we can just go ahead and add down the columns. 2 and 0 make 2. 7 and 4 make 11, carry the 1. 1 and 9. Where's the decimal point have to go? Between the 1s. How are we at 91.12? Good deal. Dividing decimals is a little bit more tricky. I have 48.734 divided by 3.2. Now, of course, we'll set it up like this to do long division. But how do we divide by a decimal? Well, the answer is we try not to. We don't. What have you always been taught to do? Take this decimal point and move it over to the end of the number. How many places did it have to go? 1 place. So what do we have to do over here? Move that decimal 1 place. Well, why can we do that? Well, we've talked about it a little bit before that fractions and fractions and division are very interrelated. They're two different ways of expressing the same thing. So I can express this division as 48.734 over 3.2. And if I want to get rid of the decimal point on bottom, if I multiply by 10, it becomes 32. But if I multiply the bottom by something, I have to multiply the top by the same thing. So that makes that 487.34. So when I'm moving those decimal points over, the same number of places in each number, what I'm doing is multiplying the top and bottom of my fraction by the same number. If there were 2 decimal places here, I would have multiplied by 100. And 3 decimal places, I would have multiplied by 1,000, and so on. So this problem now becomes 487.34 divided by 32. Let's say I tell you that I want this to the nearest thousandth. So let's do that. 32, does it go into 4? No, so we'll leave it blank there. Does it go into 48? Yes, 1. So we're going to subtract 32. Get 16. I'll bring down my next number, next digit, with a 7. Does 32 go into 167? 5 times. 5 times 32 is 160. We subtract, we've got 7 left. Before I can bring down this 3, what do I have to do? Move up the decimal point. I can't cross the decimal without doing something with it. Multiplication is the only operation in which we ignore the decimal point. Addition, subtraction, division, when we cross the decimal point, we need to do something with it. We need to carry it into our answer. So move the decimal point up. Now we can bring down the 3. 32 goes into 73 twice. That'd be 64. Subtracting gives us 9. Well, we bring down the 4. 32 goes into 94 twice. 64. Subtracting gives us 30. Each time we subtract, we need to make sure that what's left over is smaller than what we're dividing by. So far it has been. Now I'm out of digits there, but I said I wanted it to the nearest thousandth. Do I have to stop here? No, I can add a 0 on the end of it and bring that down. 32 goes into 300. Let's try 9 times. 9 times 32 is 288. Leaves us with 12. Now we're done. We're to the thousandth spot. No. I have to go one more place. I have to put in one more 0 and bring it down. 32 goes into 120 3 times. That'd be 96. The reason I had to go one more spot was because I want this to the nearest 1,000. And this is my thousandths place. But I need to know, I need that next digit to tell me, do I stay 9 or do I have to round up? Since this is a 3, it's going to stay. 15.229 is my answer. Any questions? Okay. What's that? Don't like it? Well, the nice thing about these is you can punch them in your calculator and it does them without having to adjust anything. Now, when we were talking last week about converting decimals into fractions, we briefly mentioned turning fractions back into decimals. We did 3/4. We said you're going to divide 3 divided by 4 to get 0.75. And we ended up saying we had to use our calculator for that at the moment because we didn't know how to divide. Let's take a look at how we would divide that out. 3 divided by 4. Which one's going to go inside the symbol here? The one that is getting divided. 3 is being divided by 4. We're dividing by 4, so 4 goes outside. 3 has to go inside. Now, 4 does not go into 3, so we've got to leave it blank above the 3. But there's no next digit to go to. So I have to put in a decimal point. I have to bring that decimal point up. Then I can put in a 0. 4 goes into 30 7 times. 7 times 4 is 28. Subtract to get 2 left over. And we can't add another 0 and bring it down. 4 goes into 20 5 times. That would be 20. There's nothing left over. So we're done right there. 0.75 or 0.75. So let's take a look at doing 7/8. Take 7 divided by 8. 7 goes inside, 8 on the outside. 8 does not go into 7, so I leave that blank and put in my decimal. What do I have to do before I can put in a 0? Bring the decimal point up. I can put a 0 here too if I want to. Now I can put in the 0. 8 goes into 70 8 times. 8 times 8 is 64. We subtract to get 6 left over. Now let's put in another 0. Bring it down. 8 goes into 60. 7 times. 7 times 8 is 56. Leaves me with 4. Put in a 0 and bring it down. 8 goes into 40. 5 times. That would be exactly 40. So 0.875. In your notes, why don't you try to divide out 5/16, put it in a decimal. So we start out, 16 does not go into 5, so we put in the decimal point and bring it up, and we add our first 0. 16 goes into 50, 3 times. 3 times 16 is 48. Subtract to get 2. Add another 0. Bring it down. 16 into 20. Once. That's 16. Subtract to get 4. Add another 0 and bring it down. 16 into 40. Twice. Which would be 32. Leave us with 8. At this point, you're probably starting to wonder if this one's going to come to an end. Well, another 0 and bring it down. 16 into 80. It's 5 times. That's exactly 80. So 0.3125. How many of you got that? Good deal. Okay, well, our next step, we're going to add these fractions and decimals into something we've been doing since the first couple of weeks. It looks like this. 2.8x plus 3.4 equals 9.2. What are we going to do to solve this? Very good. Just like we would any other equation, x has been multiplied by something and then had something added to it, so we're going to reverse that. We're going to subtract the 3.4. So 2.8x equals 5.8. Then what? Then we're going to divide by the 2.8. Which gives us x is equal to 1 point. Actually, not 1.2 point. Sorry.
Yeah,
2.07142857143 approximately. Okay. Yeah, that's right. Any questions? Yeah, if you want to divide it all out. Yeah. Yes, you would have had to move the decimal points. It would have been 58 divided by 28. We'd go in here twice, would be 56. There's 2 left over. Add the decimal, bring it up, add a 0, bring it down. 28 goes into 20 0 times. Add another 0. 28 into 200 goes 7 times. 7 times 28 is 196. It's 14. Go from there. Not 14, 4. Sorry. And let's keep going from there. So you hit whatever, yeah, to get as far. This one actually would never divide out. It would keep going forever. Yeah. Oh, come on. Let's try another one. Let's say 2.1x minus 1.8 equals 4.8. Have you tried that one in your notes quick? So what's step one going to be? Add 1.8. So 2.1x equals 6.6. And then divide by 2.1. X would equal 3.142857143 approximately. At this point, I'm going to trust you either divide it out or you're going to use your calculator, one of the two. I have no problem with decimals with using your calculator. That's one of the reasons why decimals have come into play, is because you can use the calculator on it. Any questions? Well, then what if we try something like this? What's going to happen with this one? What do we have to do first? Perfect. We have to get rid of one of the x's. Get rid of the smaller ones. We're going to subtract the 2.3x. Make it go away here. These are just 1.1 on that side. On this side, the only place we're going to subtract 2.3x is from the 3.7x. That's going to give us 1.4x minus 4.3. Then what do we do? Add 4.3. So it's gone over here, giving us 1.4x equals 5.4. And then divide by 1.4. X equals 3.85714.286 approximately. Any questions? Come on. Let's try another one. Tell me what to do here. Combine 0.9x with 1.3x. What's that give us? It's 2.2x. Good. We still have the positive 2.3 there. Equals, we got 7.9 over here. Now what? Subtract 2.3 from both sides. So 2.2x equals 5.6. And then divide by 2.2. X equals 2.54545.
That one would keep going where that's.
Yeah, 545454. Yep. What do you think? Yeah. Well, I said the nice thing about decimals is they do work really easy on the calculator.
I bounced around a lot in school, so I was younger, so I knew decimal.
Sure. Okay.
485.6345, and it'd be like round to the nearest 10,000. Depending on where the number was above 5 or below 5, you would have rounded up to a certain level.
Yep.
And some of those were changes.
Something like this and round to the nearest 10,000th, okay? Really, the hardest part of this is to find the 10,000ths digit. So you're starting at the decimal point, you start out tenths, hundredths, thousandths, 10,000ths. That's the one you want. The other way you can do that, write out the number 10,000. How many zeros are in it? 1, 2, 3, 4. So 1, 2, 3 is the fourth place. So now I'm going to look at that next number. The 7 tells me that has to go up to a 6. Everything else stays the same. That's it. Everything else after it is gone. Now here's the one that I catch people on a lot. Round to the nearest hundredth. Actually, that's not what I wanted. Let me change this just a little bit. Put that in the wrong spot. Something like that. Round to the nearest hundredth. So I look at my hundredth place, tenths, hundredths. It's right there. That's my hundredths place. I'm rounding off after that digit. I look at the 4, and yeah, it's less than 5, so it stays the same. 273.56. I will catch several people doing this. Now this 8 rounds that up to a 5. No, that's a 5, so now it rounds up to a 7. You cannot double round. When you round a number, you are only looking at one digit. So if I take that 5 out of there, remember when we round, what we are asking is which one is it physically closest to. So we're looking at a number line. Here is 0.56, 273.56. Over here is 273.57. And you're asking which one is it physically closest to? Well, somewhere in the middle here is 005. But we are at 489, which is going to be just short of that. That still goes back here because it is less than 5. So you can't round it up to 5 and then use that to round up. It is less than the halfway point where it is. It's going to round down. Any other questions? Okay, it is our break time, so let's go ahead and take 10 minutes. We'll come back at about 4:30 and we'll start up again.